So where did we, what was it, one plus root 3 over 3? All right, so to simplify, to finish simplifying this, we can't have square roots in the denominator, right? So I got to get rid of this root down here. How am I going to get rid of that root in the denominator? Almost. Not the exact
1 plus, so
yeah.
it's just the same thing we're doing. That's what it is.
Yeah, so to get rid of this root in the denominator, we're going to multiply numerator and denominator by the conjugate of the denominator here. Yeah. So we can multiply top and bottom by 1 plus the square root of 3 over 3. So the reason that we do that, in the denominator, some terms will end up canceling out. Right? If we start foiling, 1 times 1 is just 1. Then we'll have 1 times positive square root of 3 over 3 and 1 times negative square root of 3 over 3. So those middle two terms will cancel out. And then we'll have negative square root of 3 over 3 times positive square root of 3 over 3. What's that going to end up being? The square root times the square root just cancels out, right? So if we've got negative, I can write it out here, negative square root of 3 over 3 times the square root of 3 over 3. Well, this would be 3 in the numerator over 9 in the denominator. 1 negative sign makes it negative, so we can reduce that to negative 1/3. So we end up with 1 minus 1/3 in the denominator. In the numerator then, we will multiply this out, and we'll end up with 1. Since we're just squaring a term here, we'll end up with square root of 3 plus the square root of 3. Right, the square root of 3 over 3. So that'll be 2 times the square root of 3 over 3. And then if I multiply these final two terms together, just like we did here, square root of 3 over 3 times the square root of 3 over 3 will be 1/3. Alright, so I can now combine a couple of terms, and I can add the 1 and the 1/3 together. That would just be 4/3 plus 2 times the square root of 3 over 3. And that's all over 1 minus 1/3 would be 2/3. So I already have common denominators between my two terms in the numerator. And I can go ahead and add those together and just make this 4 plus 2 radical 3 over 3. Now, if I'm dividing by a fraction, that's the same as multiplying by the reciprocal, right? So instead of writing this as divided by 2/3, I can write this as times 3 over 2. Now, by multiplying fractions, I can actually cancel out these factors, the 3 in the numerator and the 3 in the denominator. And we end up with 4 plus 2 radical 3 over 2, which we can simplify that a little bit further. Each of these is divisible by 2. Right? So this actually just becomes 2 plus the square root of 3. Right? So that's an ugly simplification process, but we actually end up with a fairly nice answer at the end. Right? But all it was, take what we did yesterday, just plugging values from the unit circle into our formula. Right? I did get a little clarification yesterday from Stark State on what they expect you to have memorized and what you'll get on the test. You do not have, for this chapter, you do not have to memorize the unit circle. You will get the unit circle on the test. However, a lot of these formulas that we're talking about, you will have to have memorized. Okay, like so for the sum and difference formulas, the paper that I gave you yesterday, the sine and cosine ones, you have to have memorized. You don't have to memorize the tangent ones. Okay. Okay, so for the ones that we're talking about now, the sum and difference ones, you need the sine and cosine ones memorized, but not the tangent ones. And before we do a quiz or a test, I'll give you a paper that says, you have to have this memorized, you don't have to have this memorized.
You explain second.
This one? So how to get from here to here? Yeah. So in the numerator, I already had like denominators, so I went ahead and added those together. But then if I'm dividing by a fraction, that's the same as multiplying by the reciprocal of that fraction. Yeah. So instead of dividing by 2/3, I just multiplied by 3/2. And then whenever I get factors that are the same, I can cancel those out.
Thank you.
Does anyone ever actually divide by fractions, or do you always just multiply by the reciprocal?
If you're doing it by hand, you just multiply by the reciprocal. I mean, you can put it in the calculator if you're not asked for an exact value, if you just want a decimal approximation, you can put it in the calculator as divided by 2/3.
Is there a way to divide by a fraction without doing that?
Yes.
Oh, yeah. I find this intriguing.
I mean, if you think, it's more of a conceptual idea. Like if you think about do an easy one, 1 divided by 1/3. It's just asking you how many thirds are in 1. There are 3/3 in 1
So
whole.
it's kind of like on the graphic that shows like 1/3 is the B value, then 6 pi is your.
Yeah. It's just conceptualizing fractions. Yeah.
It makes sense with low numbers, with big numbers.
Yeah. Right.
It's like 4/5.
20 divided by 4/5.
Yeah.
How many 4/5 will be in 20? 25.
No way.
We just did it.
Don't make me seem stupid. You did that enough yesterday.
I just multiplied by the reciprocal.
Yeah, he multiplied
20 times 5.
Yeah, I guess they are even numbers. I should have done 23 and like 5/8. You can't do that in your head.
20 and 5 by 5.
23.
So it would be 160. 184.
I believe in you, Fetch.
So that's 36.8.
Oh my god. No way.
Wait, what?
Wait, he actually did that in his head.
That's 100% exactly the right answer.
Wow. Alright.
Mr. Fetch, you're a god.
That's
I
like,
can just do a little bit of mental math.
yeah, that's kind of insane.
Do you think anyone other than a god could do that?
Yes, because
I
I'm
disagree.
not a god.
I disagree.
That's insane. I can't do mental math.
You just have to break it down. So like, you're doing 23 times 8 over 5, right? Because 23 divided by 5/8. So I did 20 times 8, which is 160.
Add 3 times.
Then added, so I got 184. 160 plus 24, 184. And then I thought, well, I got to divide that by 5. So I know 5 times 20 is 100. Then you just start adding pieces on. So 5 times, then it's another 17. 5 times 17. But you could break it up smaller. 5 times 17 will get you 85. So that's 185. But we need 1/5 less than that, which is 0.2. All right. All right. So between yesterday and today, we've looked at one example of a sine, one example of a cosine, and one example of a tangent using our sum and difference formulas. So today, then let's take a look at a couple other types of problems still using these formulas. Okay. So this first one says find the exact value of sine of 63 times cosine of 27 plus cosine of 63 times sine of 27. So if you look at your formulas there for the sum and difference of sine and cosine, this actually fits one of those patterns. Right? So sine of, we can call 63 degrees our A value and 27 degrees our B value. So sine of A times cosine of B plus cosine of A times sine of B. Which of our sum and difference formulas fits that? Fits that pattern.
So that would be sine. Would be no, cosine is both cosine on one side, both sides on the other. I don't. Wouldn't that just be a sine addition?
This is the sum formula for sine.
I gotta find that.
Let's go. I didn't even have my paper out.
So this is just going to be equal to. This is just going to be equal to sine of A plus B. So sine of 63 plus 27. And adding those two angles together. 63 plus 27 is just 90. What's the sine of 90 degrees? You said it's radical 2 over 2?
No.
1.
Yeah.
Told you. Sine is the y value.
I can figure out.
Sine is the y value on the unit circle. So at 90 degrees, the y value is just 1.
I didn't know that.
So as you're doing these problems, right, use your unit circle. Okay? We just found out you don't have to have it memorized for this chapter. So use it as you're doing these problems. Right? You will get the unit circle on the chapter test.
Do you have any more of those sheets with the identities on?
The ones that I gave you yesterday?
Well, yeah.
No, I do not.
Let me see if I have it in here somewhere. I might have just misplaced it.
Okay, so problems like this. Problems like this, where we are just going backwards. Okay, we just need to recognize which form of our sum or difference identity we need to use. Okay, so in this case, we were using sine and adding the angles together.
No, here it is.
We may be given one where we have the setup for the difference formula for cosine. Okay, we just need to recognize if we need to add or subtract the angles and which trig function to use here. All right. Questions on something like this? All right, then let's take a look at something like this. So on this one, we're given a couple pieces of information. It says sine of u is negative 3/5, and cosine of v is 12/13. And then we know that u is in between pi and 3 pi over 2, and v is in between 3 pi over 2 and 2 pi. We want to find the exact value of sine of u plus v. Right? So this is that same formula that we just used. Right? So So that'll be our sum formula for sine. I can split this up as the sine of u times the cosine of v plus the sine of v times the cosine of u. So what we need, okay, we already know the sine of u and the cosine of v. I need to solve for the sine of v and the cosine of u. To do that, we're going to have to set up right triangles. Okay, we've already done problems like this where we set up a single right triangle and solved for some missing sides. But now we're going to have to do it twice. Okay, we have two different angles. We have a u and a v. So let's deal with the first one. Let's deal with u first. So we're told that u is in between pi and 3 pi over 2. Which quadrant is that? Third quadrant, right? So we can sketch out our triangle here. So this is angle u, and I know the sine. So sine is opposite over hypotenuse is -3 over 5. So we just need to solve for this side in my right triangle in order to figure out what cosine of u is. If you recognize that this would be a Pythagorean triple, that'll save you a little bit of work. Okay, this will be a 3, 4, 5 right triangle. If you don't recognize that, you can always use the Pythagorean theorem to find this missing side here. So we could set this up as a squared plus b squared equals c squared. -3 squared plus b squared equals 5 squared. When we solve this, we'll end up getting that b is equal to 4. However, since this is in the third quadrant, this is a negative x value. Right? So this is really -4 here. So the cosine of u then will be -4 over 5. Now, I guess could have filled these in as we were going. We know the sine of u is -3/5. We know the cosine of v is 12/13. We just now solved for the cosine of u. -4/5. We still need to get the sine of v. So I'm going to need to create another separate right triangle here. Now they tell us that v is in between 3 pi over 2 and 2 pi. So what quadrant is that? Fourth quadrant. Right. So draw my right triangle over here. Fourth quadrant. This is angle v. And we know the cosine of v. So cosine is adjacent over hypotenuse. 12/13. What order? Oh, yeah, I think on your paper it's
Okay.
cosine of u, sine of v. Yeah, since we're multiplying, these two things can be flipped, yeah. So this is actually another Pythagorean triple, right? But if you don't recognize that, you can always do the Pythagorean theorem. But this, I'll skip the Pythagorean theorem for this one. Right? This is the 5, 12, 13 right triangle. But since I'm below the x-axis, this is a negative y value. So the final thing I need is the sine of v. So sine of v will be opposite over hypotenuse. It will be -5/13. So we are finding the sine of u plus v. So if I were to add these two angles together, it's going to be some ugly angle. But I'm going to get an exact value for the sine of if I were to add these two angles together. Okay. So just have a little bit of arithmetic to do now. Right? Multiplying these fractions together, we'll get negative 36 over 65. And then here, we have a negative times a negative, so that'll be positive 20 over 65. Then negative 36 and 20 would be negative 16. So for this problem, the exact value of sine of u plus v, negative 16 over 65. To use our formula though, we had to set up and solve two right triangles to get another sine and another cosine value. Questions on something like that? Do we want to try another one of those, or do we think we're all right? All right. Well, that's pretty much all I have for you today. Then, so we've got a little chunk of time to work on some homework.
Okay, that's what I'm doing. Because I'm a silly boy.
That should be an idea, I would think.
Yeah, it happens sometimes.
All right, let's do page 641. Yeah.
No. No. Good question.
Just wanted to make sure that I wasn't.
All right. Page 641.